Hi everyone. So today we are now going to learn about unsupervised machine learning. Machine learning. So as a part of this, we are going to discuss about k-means clustering and also principal component analysis. So now let us try to understand how exactly they work with mathematics. Okay, and then we will also going to discuss about how we can implement those concepts with Python. Okay, step by step we will see because these two techniques involves a very good mathematics behind it, because so far we understood about how supervised machine learning algorithms works. For example, in we learned in supervised we learned some data set will be there, right? Just revising the concepts, x1 x2 and target will be there. Okay, if this target is what we wanted to predict. Why? It is also called as what we wanted to predict. Okay, these two can be say as X, that is also called as inputs, input features, right? So this is what we discussed in supervised. If this target data is two types, distribution according to distribution. If it is continuous, then we have to decide the regression regression problem statement, regression related models, regression models we can use to predict. If it is discrete, okay, so we have to use classification algorithms, right? So this is what we learned in supervised machine learning. So now machine learning, now when it comes to machine learning, what we extra going to learn is we will be having again data set for sure. Okay, we will be having data set. So let us consider this is a small data set with some points x1, x2, x3, x4. But here I don't know what column can be target. Target column is not known, unknown. But we will be having inputs. These are all inputs or features, simply features. Now, what I wanted to find out is I wanted to find out a mathematically a pattern where I can group them as clusters. Okay. So by doing this, what can I do? If there is any new point came, okay. So I have to decide new point belongs to which cluster, this cluster or this cluster or this cluster. If I can able to do this, then I can able to do the machine learning part, and I can do prediction perfectly. So ultimately, machine learning requires to predict something, correct? So this is what we are going to learn. How can this can be possible? How this can be possible? Okay. So observe this one. We are using, as a part of unsupervised, we are using technique called clustering. Clustering. So one of the clustering algorithms is k-means. There are along with k-means, there is hierarchical clustering is there, DB scan is there. But now in this, as a part of this course, going to we are going to learn about k-means only. Okay. So before k-means, let us say these are all x and y. Okay, these are all features. We don't have any target value. Okay, but we have input variable like input. Like we will have some input data, right? If we can plot them, let us say these points are like this. Now, if we can perfectly cluster them like this, here you can see this is one cluster, this is another cluster, this is another cluster, where k is equal to 3. K is a scalar, as I already mentioned in the last class. K means and KNN, both algorithms, there is having one, commonality. K is a scalar there also, here also. We have to use this K effectively. So if K is equal to 3, then the target is out of these data points, I have to make three different clusters. For example, if K is equal to 4, then what will happen? Maybe I can assign one more cluster here. This is fourth cluster. So we can use, let me remove this one. Okay. Instead, okay, instead of this, this is one more cluster. Now four clusters are there. Okay. As k is equal to 5, then this part can be fifth cluster. Okay, likewise, my target is what is the k value. Accordingly, I have to cluster them properly so that the future points I can easily predict according to the regionality of those. Okay, if that point relates to cluster 1, then it will predict as cluster 1. Got it? Is that clear? How the clustering works? Now, if it is clear, then we can discuss about what is this algorithm mathematically, how it is possible. If I say that yes, grouping, if you can make clusters, then it is easy. That is high level understanding is okay. But how can it possible with the help of mathematics? That is what the very confusing topic, right? And also most curious topic. But before going to that, is it clear? Like, can I get a quick confirmation from any one of you how exactly clustering works? Hmm? Is it clear how is clustering works? Hmm? Okay. Uh,
Yes, Yashwant.
yeah. Cool. Yes. Now we will understand how this is working, how this works. So it involves some set of points. So that is why I have prepared these notes in a very understandable way. Easily you can understand. Okay, let us consider this is what our data set. Okay, X, Y, some data points are there. Okay, if you plot these data points, this is the one you will get. Okay, I don't know which is the target value, which is the input value. I'm having just a simple points. If I plot them in two dimensional, this is what the graph I got. Okay, so here 1 point, 2 point, 3 point, 4 point, 5, 6, 7, 8, 9. According to this plot, can anyone tell me how many clusters we can make? A random guess, just a random guess. Anybody would like to?
Um, Two.
Okay, so let us plot that. Okay, so Maria is suggesting me two. So for example, this is one cluster. If k is equal to 2, then the target is to make only two clusters. Okay, if you feel that it is like this cluster is okay, but this cluster can be further, clusterized, then if you want to increase the cluster size from 2 to 3, okay, let us say k is equal to 3, then maybe this is another cluster and this is another cluster. So simply it is depending on the k value. Is that clear? First point, is that clear?
So I have a question.
Yeah, please, Maria.
Uh, so like I like my thought process of telling two was I was considering the farthest point, like the point here at 1 and 2, and then the point at 2 and 10, 2 comma 10, as outliers. So can we like do we have to have clusters for all the points? Like to include them, like what is the best practice, like, or can we leave them as if we do k is equals to 2 also, can we consider them as like outliers and just go ahead with two clusters? What is recommended, like having more clusters or ignoring outliers?
Very good question. Good question it is. Very good. So here, what if we have outliers? See, let us consider this is an outlier. Okay. Then if you see three clusters can be this is very good. One, two, three. Even if we leave it apart. Then there is a concept, another concept is there that I will explain. Anyway, you touched that point, I will explain that concept. But before going to that, uh, and one more question of yours is also good, like how we decide the k value, right? So how we can get the optimal k value, which is I mean how many clusters that I can make. For example, here out of this picture, anyone can tell me like how many clusters can form. But in real time data set, it is sometimes difficult to find out the optimal k value, isn't it? That is the question, right, Maria? Another question.
Yes,
Got it,
yes,
right?
yes.
One is with respect to outliers and one is with respect to k. That is, those two are the questions, right?
Yeah, like
Very
how
good.
many k values we need to pick, and then if in between k values and cluster, like outliers,
Uh-huh.
what do we focus on more? Like, do we focus on getting more clusters, or do we focus on ignoring outliers? Like, what is the best practice?
Okay, very good, very good. So in this particular concept, I am going to cover both the things. Okay, and first of all, how this is mathematically working. Let us try to understand that how the grouping is mathematically working is. So, for example, okay, the concept is, for example, if you define out of this picture, let us say k is equal to 2 or k is equal to 3. First of all, we need to decide step 1. It has some steps. Step 1 is decide k value. And how to decide the optimal k value, we will discuss that later. But before that, it is a mandatory thing. First of all, we need to come up with a k value. For example, k is equal to 3 or k is equal to 2, any value. Okay, either k is equal to 4, 5. Obviously, 1 is not the optimal one, right? Everything cannot comes under one cluster. So k1, we will max skip that. Okay, k at least 2, we will keep it, and k is equal to 3 or 4, it is up to your choice. We will observe the results obtaining at each iteration, and we will fix what is the optimal value. That will be discussed in later part. But first of all, we have to choose k value. Let me decide k is equal to 3. If I decide k is equal to 3, some random points out of here, I need I need to select 3 points as centroids. Any random points. For example, this point, this point, this point. If I choose 3 means 3 centroids. Step 2 is centroids. Centroids. Okay. I have to select 3 centroids. This is one centroid, let us say, means 6 comma 4 and 2 comma 5 and 5 comma 8. These three are centroids. I have to calculate the distance between these centroids to every point. Okay. You know the distance already we discussed in K, N, N. We have different type of distances, Manhattan distance and Euclidean distance. These two derived from Minkowski also we discussed. If P is equal to 1, then Manhattan, P is equal to 2, then Euclidean. Let me decide here Euclidean distance, but it is most optimal use. X2 minus x1 whole square plus y2 minus y1 whole square root of. Okay. This is what the formula which I can use to calculate the distance. Now, for centroid 1, this is centroid 1. What is the distance between from here to here? Okay, all the three centroids, the distances. Okay, so here I just given here. Okay, first let me consider these three are the initial centroids because it is got decided randomly here. I also mentioned randomly, and that random selection is happening on your data set only based on the value what you decide. K is equal to 3 means 3 centroids. Then Euclidean distance formula, we know that. Okay, Euclidean distance going to calculate here. You can see C1 centroid for this point. This is what the value of centroid with respect to centroid. Okay, so same way, just I discussed here. Same way, first, what is the distance between centroid C1 to this point? Centroid C1 to this point. Centroid C1 to this point. This point. This point. This point. This point. And this point. These are all C1. C1 distances with respect to C1. Similarly, C2. Similarly, C3. First, we need to calculate such distances. Once you calculate the distances for the first point, okay, 2 comma 10 point, out of these three centroids, which is the minimum value? You have to identify the minimum value out of these 3 points. What is the minimum value? Can anybody discuss? Can anybody would like to share for the 0th point out of three centroids? Which distance is less with respect to this particular point?
Zero.
Hmm?
C1.
Very good. What about the fifth point? Fifth point.
C2.
6
C2.
comma 4. This is C2. Very good. The same operation that I am doing here. Just calculating the minimum. Okay, ID minimum. IDX minimum means simply out of this particular thing, which is the minimum, it is what it will take, and then it will write that particular column. If this column is C1, that is why it is showing as C1. Similarly,
That's a built-in function, IDX min.
IDX min, what is that, Maria?
What is it?
This
Is that
IDX min,
built-in?
this is a pandas function actually. IDX min,
Okay.
ID minimum. See, for example, this is the ID, first ID, because access is equal to 1, we discuss. Access are either can be 0, either can be 1. If you are putting 1, it will go ahead and will check the rows. Okay. In the particular this particular entire row, which one is the minimum value? C1 is the minimum value. It will give that particular column name. So I am just mentioning that C1, C2, C3, out of these particular three columns, whichever is the minimum value, you give me that particular value as here. Got it?
Okay, got it.
Okay, if you put ID max, max is also there. It will give you opposite way. Maximum value it will show you. Okay,
Okay. Yeah.
very good. Then this is what I got as fifth point we discussed C2. Got it? So now the clusters formed. Okay, now these are the clusters formed. Okay, with respect to the centroids. But these are random points, right? C1, C2, C3 are random points. We did not uh, like find out optimally. If that random points, we cannot judge an algorithm pattern out of the random points. We have to fix it properly. Correct. So how do we fix it means? So see, this is the representation C1, C2, C3. Just I plotted where are C2 points means. Let me take this and put it here. Okay, here we can see this is green color is C1. So green color is C1, whereas C1, this is the C1. Okay, let me drag a bit. Now hope this is clear to everyone. Because this is very important. Hmm. Yeah. So this is C1, right? And this orange one is C3. Okay. And the blue one, all these points comes under C2. This is C1. Okay. Now tell me, is this a proper? Do you feel that this is a proper, clusters? These do you feel these are proper clusters? Hmm? Obviously, no, right? So then
Yeah.
how? Correct, right? Obviously, no. These are not the proper clusters. What we are looking at. So how do we then decide the best clusters means? So now we have to find out the mean value of these clusters. Means what are the C1 values are there? How many C1s are there here? Only one C1. So find out the mean of these three. Okay. Similarly, how many like how many C2s are there? C2s are this point, second, third, fourth, fifth, and then seventh. These points, okay, 8 comma 4. I mean to say not these mean. I mean to say the XY means. Okay. Here you can see. Okay. The first value anyway only 1 point is there. That is why by default 2 comma 10 only came. Okay. So C2 there are 4 points. So 4 points means. So these are called the new centroids. New centroids came from the first centroids. Those are simply arranged and get the mean values. Okay. For that purpose, I am using the group by. I can use group by, and then I can get the mean value. I just wanted to convert this into the data frame. That is why reset underscore index. We already discussed this. So now what I'm going to do is, instead of having outer point, I don't like to have these many points out of outer point. So I just converted to two max points. Okay, here you can say rounded. I just rounded. That's it. These are the new centroids. What I'm going to do is, see here you can see these are the new centroids which came after the assumption of first thing. Then what we are doing is simply again we repeat the first step. What is the step two after k selection? What is the thing what we did? We selected three clusters randomly, and then we find out the distances between everything. Now with the help of the new recent centroids, again we are finding out the distance. Okay, so this is what the C1, C2, C3 we got. New C1, new C2, new C3 with respect to these centroids. Okay, these are the older ones. This is the new one. Again, I'm adding one more column called minimum to just get a minimum out of this. Now these are the new ones. Now what we have to understand is, okay, now what we have to understand is, observe the C1 and you have to estimate whether the new value and the old value is same or not. Here C1, yes C1, C3, C3, C2, 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 C3 as C3, but C2 as here it is identified as C1, isn't it? It is identified as C1. And here again C2, C2. But we also have to convert that the randomness is here up to here it is true. Randomness is up to here it is true, but here it failed. So we have to even correct this. How we do? Again repeat the step. We will now take the group by on this particular minimum new and again calculate the mean values of x and y. These are the new centroids. Okay. Now these are the new centroids. Considering these are the new centroids, again calculate the Euclidean distance and added a new minimum value. Now compare the minimum new with the minimum new 2. Now C1, C1, C3, C3, C2, 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 C3, C3, C1, C1, C2, C2. Got it? So now we did not get any mismatch. So this is what the fixed one. This is the new one. Until unless you get the clusters correctly, so you have to keep on change the you know centroids and then calculate the distance between them. You have to get all the related points club and come into the same group. That is the main goal of k-means clustering. It depends on the k value. Here I'm just plotting the now the recent one. Okay, here you can see according to this picture, updated values, what are the final values are. Okay, so these two belongs to one cluster, and these points are one cluster, and these points are another cluster according to k is equal to 3. If you go ahead and use k is equal to 4, then what will happen? 4 centroids will be taken out, and then distances means x. C1, C2, C3, C4 will come, and then minimum column. And which one is the minimum? Then C2 is minimum. Let us say C2. Likewise, you have to calculate every minimum and those minimums plot. If you identified it is not the one what we are expecting, then again change the centroids. How to change the centroids? Take the mean value. Mean according to the minimums. According to the minimums. Group them all C1, C2, C3, C4. Take the mean of x and y, xy. Mean of x comma y, mean of x comma y points, mean of x comma y points. Now these are the new centroids. Considering these new centroids, again calculate the distance between every x and y, and again take out the updated minimum value. Likewise, you have to repeat it until unless you get the optimal value of optimal value of k. Okay, so now we cannot here see k value. According to the k value, what I wanted to do is I wanted to randomly pick my initial centroids. Here I picked up manually, right? I picked the centroids manually, but I wanted to perform an algorithm way, which has to perform the same steps. Then this is the final code algorithm building. Here you can see points means the data set if you can pass, then if you can mention the k value, What is this max iter values means? How many times you wanted to repeat? We just repeated for 3 times. They're identified. But if you can go for further step, maybe again you will get the different values of C1, C2, C3. Maybe you have to get the some other way, like the best optimal values as clusters. I just repeated it for three. But max iter, if you can increase it to another number, you have to repeat that many times. Got it? First step is randomly initializing the points according to the length. For example, here k value is 3, then 3 points will be picked. 4 means 4 random centroids will be picked. We're going to pick and then initialize those as centroids, initial centroids. After that, we will just run a for loop. First, calculate the distance between them, then initialize that arg minimum distance we want, right? This is another way. ID minimum, IDX minimum is there, and arg minimum is also there. Anyway, this np dot arg minimum we already discussed in NumPy. Here we can use that. Okay, we will get the lowest index. That is what arg minimum. Okay, new centroids. These are the new centroids. Okay, so this is has to be iterate up to how many max iter. If you are 10 targeting 10, then 10 times you have to repeat. Then finally you will get the cluster labels and centroids. This is what I am just taking out. For example, these are my points and I just pass it. This is a data set. If I mention k is equal to 3, then these are the ways. See, this is one centroid, this is second centroid, and this is third centroid. Is that clear? Is this clear? How the k means clustering is working? If you go ahead and change the k value, you will get different centroids. Hmm? Or is this K means
Yes,
clustering
Yashwant.
is clear? How exactly it works?
Yes,
All the
Yashwant.
yeah. So this is the actual mathematics behind K means clustering. Now let us experiment these things. So just by these are the initial centroids. You can also initialize your own centroids and try. And these are the way. This is the way I'm just considering every time new column and then trying to show you how exactly the things are going to happen. And new centroids. These are all manual implementations one by one. But if you wanted to implement as a part of an algorithm, okay, you want to define your own algorithm instead of K, instead of scikit-learn. Behind the scikit-learn, this is what the exact thing happening for every machine learning algorithm. We are just using fit of x train comma y train. But behind fit, this is the way how you can also build your own algorithm. If you are able to build your own algorithm according to the mathematical formulas, then you can become machine learning engineer. Okay, those who would like to become machine learning engineers, they have to be very strong in mathematics and then coding. Okay, so that you can build such functions based on mathematics and Python. Python means Python or Java, any other language. Okay, languages not matter, right? When we are going to implement the mathematics and all, right? So here we can see this is what the algorithm that I just consider this with the help of mathematics. Simply, I just mentioned, please go through. You will definitely understand this, what I have performed here. And then testing the algorithm. Here, this is what the data set. And then now I would like to go for k is equal to 4. Then observe. So 4 clusters we have to 1. This is 2. This is 3. But this one point is an outlier. Obviously, Maria was right. Right, this point is actually telling this is another cluster. Okay, considering the outliers as one more cluster. Okay, so these three are perfectly fitted, but this is going to be an outlier. That is why it is behaving like this. When I'm giving k is equal to 3, then yes, these two one this is one more cluster and this is one more cluster. So earlier what we did is k is equal to 3 only, but here what we got is clusters. If you see here, so according to here, these two only one cluster, this all one cluster, this is one cluster because this is repeated for only 3 times. But if you repeat it for maybe 10 times, you may get very good clusters. Here you can see two. Comparatively, these clusters are The centroids you can see exactly placed in the center, right? The centroids are placed very correctly. So if you consider this one, then if there is any new point comes into the picture, then you can easily insert that in the particular cluster so that you can define correct group, okay, correct characteristics. So this is one cluster, this is second cluster, and this is third cluster. Very nicely formed because here we iterated for 10 times. If you go ahead and try for 100 times or 20 times, you will get most optimal value. So that is why max iter is hyperparameter here, and number of clusters k is another hyperparameter here. Then the second thing, okay, we understood how based on the k value how these clusters are forming, we understood. Then what about the k value? How do we define this k value? We can use two different ways. One is using Shirauti score, and second one is elbow method. Elbow method is in common. Shirauti score can be useful as a metric. We know the metrics, right, in machine learning. For example, in supervised machine learning, you have learned about r1 square and sum of mean square, I mean mean square error, and such things, right? In regression, in classification accuracy, f1 score, precision recall, right? Confusion matrix, classification report, all such things are metrics in classification. But when it comes to k-means, we can use a very one popular thing, which is Shilautte score. Okay, Shilautte score is what we will discuss here. How do we define that? Okay. So before going to that, I just wanted to show you with the help of small data set. This is a small data set where I'm having name, age, and income. I don't have any other particular. See, I don't want to predict the income based on the age. I just wanted to group them. Okay, I just wanted to group them into clusters so that which cluster they belongs to. Accordingly, I would like to predict the income. Okay. So here you can see this is what the first the data set. And then if I plot the age and income, only age and income, these are the values that I got. Out of this scatter plot, I can easily say see, k is equal to 3 is what an ideal value here. Right. So I used k is equal to 3. See, algorithm wise, you can see the real time. We just needed to import the scikit-learn k-means. From scikit-learn cluster, you can import the k-means. Inside this k-means, you have to pass k is equal to 3. The default values are there. So k means in scikit-learn, if you observe sklearn, okay, if you observe this k means, see, first initially by default 8. Okay, you have to alter that to as many as you want. Then initialization is k means plus plus. By default, it is k means plus plus. I will explain you what is this k means plus plus. Okay, and max iter you can see by default it is 300. 300 times. Okay. And tolerance, verbose, random state, it is none, copy X. These are all. You can go ahead and understand what they are, but they are not very much being used in general. N clusters, initialization, and max iter is these three are very important to check it out. Okay. For example, N cluster by default it is 300 max iters. That is good. If you want, you can alter them to 100 or 200, 500. You can check with that hyperparameter later on. Initialization by default it is k means plus plus. What does that mean? I will explain you later that. Okay. But before that, just try to understand. See, this is the way how you can use the. First of all, let me run this. K means this was not run. That's why we got an error. This is a data set calling, and then here km here k means that's a km. Number of clusters here I just given k, n clusters is equal to 3, and then I just predicted. Okay, age and income I just passed. Then the first value of age and income, for example, this value 27 and 7,000 income. belongs to cluster 0. Okay. And then cluster 2. The second point is cluster 2. According to that particular pattern. Okay. According to that particular pattern. So if I wanted to use another column called cluster, I wanted to prepare one more cluster column. I just wanted to use all these values as its rows. So 27, 7,000 cluster value 0. Okay. I just wanted to see what are all the values which belongs to cluster 0. How can I do? Simply df of cluster. This value I wanted to check it for 0 initially. These are the values which are having 0 cluster values. So these are the 0 cluster. So all these belongs to 0. Okay. Second thing I wanted to see, cluster value as 1 is equal to 1. And then cluster value is equal to 2 because we have three clusters. So these points only belongs to cluster 2. According to the mathematical pattern between, see how these clusters are formed. I already explained you. Initially, by default, three random points will be collected and then calculate. See, 300 times it will repeat. Then only it defined, okay, this is the one cluster. This 0 cluster is the 0, 1, 2. This is the way it assigned. In our example, we explained about C1, C2, C3. Here we explained, here they took, by default, they will take 0, 1, 2, 3, or something like that. Okay, how many points you choose? Those many centroids, default centroids, and 0, 1, 2, 3 is the labeling because computer wants only numbers, right? It cannot. Okay, so now what we can do is, if you are interested, you can use a regression problem here on age and income, correct? Age and income. You can use this cluster as another parameter because according to the cluster it belongs to this group. In general we know that one basic idea. If age is increasing, income has to increase, correct? So if age is increasing, income has to increase, but we cannot come to that conclusion. Maybe one guy who is 25 years old can become CEO of a company and earning 10x than 35 years guy, correct? So we needed to find out a pattern, isn't it? We need to find out a pattern. So and that pattern can be clustering so that we can group them to the proper clusters. Once we group them to the proper clusters, and then we can use a linear regression on top of it, making use of cluster value, and then we can predict the income value somewhat very near closely after segmentation. Is the point clear? Is this point clear? Is this point clear? How clustering can help in reality in many of the problem statements? Hmm? Similarly, if you have some products, okay, Walmart or Walmart, some products are there. There is a use case where they would like to know the prices. They would like to know the price of uh, you know any product uh, according to the festival. For example, if festival is going to come, yesterday, we celebrated in India today, but US you celebrated Eid, right? So according to that festival calendar, if any festival is there, right, the prices of the products has to decrease so that they can increase the sales. Correct. So we have to, do that machine learning model. We can build a machine learning model accordingly. So how do we predict the price of a product? We can use regression to predict the price of a product. That we know, everyone know that. But instead of that, if we can cluster them according to the customer's, preference. Okay. So if we can cluster them according to the customer preference, and then we can use a linear regression on top of it, then it will be the most ideal approach to choose or to predict, okay, the price of the product properly. Okay. So up to now we learned how to use, how to use k-means clustering by using predefined k value. we yet to discuss how exactly k value can be defined. But before that, see, center cluster centers. This function will help you to get the optimal, centroids, which are fixed at the end, right? The last iteration. These are the centroids. This is the way how to get the optimal centroids. And then if you plot that 0, 1, 2, 3, and if you plot the centroids, see, this is one centroid, this is one, this is second, and this is third. According to this particular thing, okay, these are the centroids and these are the clusters. Okay. Now tell me, anyone, okay, do you feel these clusters are nicely arranged? This is cluster one, this is cluster one, and these points are cluster 2, and these points are cluster 3. So now, do you feel the clusters are well arranged? That is the question. Hmm? Anybody? Up to now, is it clear? Everything is going good? Understanding? Hmm? Okay, I can take it as yes. Okay. If we wanted to see, instead of scikit-learn k-means algorithm, if we wanted to use our algorithm which we already built, so this is the way how we will just using the k-means. This is what we built earlier, just passing the points. Points means the data set. Okay, and then k value. Here k value is 3. So finding out the labels and then plotting them based on our algorithm. Our algorithm, 10 times only we are repeating, right? 10 times only we are repeating, right? Max iter is 10 times. But if you go ahead and alter that to 300, then maybe the same. But 10 times also the same type of output what we got. The same way. Okay, here we got one more point here you can see. But according to this algorithm, here this is the points. But according to our algorithm, this point also grouped as cluster 2. So this will get altered and fixed by changing the iterations, and then if you can get it, that you will get the optimal values. But how do we solve this? See here, if I see, this is not the way that proper clusters. This is because of you did not perform feature engineering. Feature engineering we did not perform, right. Directly we just use the data set and pass the k-means. Min max scalar and standardization normalization we already discussed. There is a very big impact on this. Standardization means the or else normalization, it will all assign the values between fixed range. Okay. If we have a different ranges, for example, income started at some point and ended at very long point. We don't know how to we group it into fixed points. For example, min max scalar is there. We can assign every point between minimum and maximum. We know the minimum value, we know the maximum value, no matter what the value of the future value, we can assign them into properly. And normalization is also the same. 0 and 1, we can assign them. But but in reality, the age can be anything, the income can be anything, right? If you don't standardize it, so we may get a different type of values, random values, right? So we wanted to fix that. That is why there is a big impact of standardization and normalization. And here, if once I do the standardization and normalization, and then applied k-means clustering on top of it, then I got these values are like this, and updated clusters are like centroids are like this. And then if I plotted, now this is cluster 1, this is cluster 2, this is cluster 3. Now if you see, this is optimal way, correct? Got it? So this is cluster 1, this is cluster 2, cluster 1, and this is cluster 3. Is this clear? Up to now, is this clear? Can I get a quick confirmation, please? K-means clustering. Is this clear? We had to cover two more concepts in K-means. One is how to fix K value we did not discuss and at and also the matrix. But before going to that, I just need a confirmation from your side whether you got the concept or not. Please respond either with thumbs up or else saying yes so that it will help me. Hmm? Any response? Wondering whether you guys are there or kept your laptops and then went outside. Uh, huh, okay. So I'm continuing. Okay. So how do we define the best K value? That is that to decide, right? So we can use elbow method. We can use elbow method. For that, I'm just considering the sum of errors. Okay. Sum of errors. So that is also called as WCSS. See, errors in K-means. Okay. That is what we will get as WSCSS. Okay. We can use that particular metric. Okay. W says in K means okay within cluster sum of space, that is what WCSS. Okay, within clusters sum of space, it is just a measure of sum of squares. uh okay, sum of squares of error, you already know how do we do the error, right? In linear regression we discussed the same way, the actual value and the predicted value and then square it up and then sum out of that particular cluster. That is what sum of squares, sum of clusters within the cluster. Okay, sum within the cluster, sum of squares. Okay, that is what, if you want to do that, we have to use this function called, I mean, this is attribute, this is called inertia underscore. If you use this, you will get by default WCSS. That is what we are taking as an error, and we are plotting sum of squares with k values. I just consider k value range between 1 and 10. Obviously 1 is not a good way. So let me go ahead and take 2 comma 10 and then plot it. Here you can see wherever you get the elbow shape, you can see the elbow very clearly, right? Elbow, right? So this is the way how do we decide k value. Wherever you get the k value of iterations, see here, I am just considering k value from 2 to 9. Okay. So 2 value, my error is very high. It is get gradually dropped. Let me use one more color. It is gradually dropped. But here I got elbow, elbow. Okay. So then I can choose 3 is optimal value. K is equal to 3 is optimal. Got it? This is the way how do we fix K value in reality. Okay. Then another concept is Shiel-Houghton score. Shiel-Houghton score is a method that can be helpful for validating our results with respect to the clusters of data. Okay. So how do we do that? Means the values are always of Shiel-Houghton are between -1 and +1. If the value within the k value is good, then we can consider that particular cluster. Of course, if you feel this concept is confusing, I have a better explanation. But before that, please see the formulation. Shiel-Houghton of formulation is B of I minus A of I divided by maximum of these 2 points. What is this B of I? B of I is simply mean nearest cluster distance, distance to the closest point. That is mean. We have to take the mean value minus mean of intra-cluster distance, distance of two other points in the same cluster. Got it? First distance between the different cluster. Okay, that is what the B, and then distance to the other points in the same cluster. We have to do the difference of those two. That is what the numerator, and the maximum of this A comma B is what we will get as a denominator. So if you calculate this particular formula, you will always get the values between -1 and +1. If you are getting close to +1, then the clusters are very well formed, very well formed. And 0 means clusters are overlapping. You did not perform. I mean, data is something we need to do the modification and all. Clusters are -1 means wrong clusters. Definitely wrong cluster. It is not at all the right way we do the clustering. So always we have to target this Sheil-Out score is so close to 1. If we go ahead and implement the Sheil-Out score, okay, here are the results. Before that, we got the, here you can see the elbow method. With the help of elbow method, k is equal to 3. For that particular thing, you can observe the Sheil-Out score is 0.71, close to 1. Then cluster 3, if we use 3 clusters, then they are very well organized and formed when compared to cluster 2 and cluster 4. You can see cluster 4 is 0.6, but still cluster 3 is having highest Sheil-Out score. That's why we can choose k is equal to 3. Got it? So there are two ways. One is based on the elbow method, obviously. Second way, we can also calculate the Sheil-Out score for different clusters. Wherever we get the Sheil-Out score is close to 1, and that particular value is what the cluster k. K is equal to that particular number we can use. So this is the overall concept of k-means clustering. But still one more concept is left out. That is k-means plus plus. What is this difference between k-means and k-means plus plus? Okay. So k-means plus plus, actually what it will do is, okay. So instead of assigning randomly, so let me show you with the help of this particular diagram. Okay, let me take a new. See, this is the points, right? Copy image. Yeah. So these are the data points, right? Earlier, what we do? So we assign k is equal to a particular number. Accordingly, random centroids we choose, right? Random centroids. But here in k means plus plus, if you use a parameter k means plus plus, okay, then what it will do is, so k is equal to 3, right? This here also we need to define k value for sure, okay. But k means plus plus will actually not going to select the clusters randomly. Okay, instead it will use one formulation to choose effective clusters. For example, k is equal to 3 in earlier, if you don't use k means plus plus, randomly 3 clusters getting selected. But if you use k means plus plus, then what it will do is k is equal to 3, right? First cluster, first centroid is random. Okay, let us say this particular point is first centroid C1. Then what it will do is C2 and C3 will not define by randomness. Instead, it will select the largest, I mean, maximum point from this distance, maximum distance from C1. These are all nearest centers, nearest distances. But when it compares to C1, this point is largest and this point is even large. Then it will consider this is C2. And I want one more thing, C3. C3 will definitely will be between, this is somewhat smallest, and here already one C1 is defined. Then this here at this region, maybe C3 here. If you go ahead and define C4, maybe this point is C4, something like that. Okay. So C1, C2, C3 centroids are not assigned by randomness. Instead, formulation and using the probability concept. Okay, it will select the C values. For example, if you go ahead and use this documentation, K means plus plus. Okay. So K means we already discussed the same steps. First, we need to assign K value, then randomly selected K points, then Euclidean distance, then assign the minimum distance, and then mean, and then find the new centroids, and then again steps until unless you get the algorithm converged and then get the less. Okay. See, centroids are has to be like that. But when it comes to the K limitation is K is chosen, we have to correctly choose. For that, we can use the elbow method, but K means plus plus. Means here you can see it is improvised version. Okay, it is unsupervised learning only, but here what we will do is initialize the cluster centers in a more intelligent way than the random initialization. Okay, here you can see the steps. First step, anyway, first cluster center by randomly only, as I mentioned. For the next time onwards, it is not at chosen a second center cluster. Compute the distance between the point and the nearest cluster center. Select the next cluster center from the remaining data points with the probability proportional to the distance squared to the nearest center. Okay, this ensure here you can see it is far away from the existing center. This is the important point. In that way, it will choose the centroids and then it will calculate again the minimum so distance. So then it will see first point is randomness, second point is far away, and it will keep on repeat. See, when it compares to here, this is the far away point, right? So and this is even far away. Like that, it will choose, and then it will go ahead and compute the k-means clustering. Is this clear?